All right, so I'm going to get started immediately because it is time to review the exam for tomorrow or on Monday. So I will be reviewing the practice exam. First, before I start, let me go ahead and just talk about the format of the exam for a second. Format of the exam will be on paper. Of course, as I mentioned previously, you get a cheat sheet front and back. Okay, handwritten or typed, I don't care. So, but you get a page of notes. So now with regards to the exam format, I believe there's around. So we have one 5-point question to get you warmed up. Then we have then we have a total of 6 10-point questions of the format. And those first 6 questions are going to be of the format method writing. So each function is going to be worth about 10 points. Make sense? So we'll start out with a 5-pointer, and then we'll start out with basically stuff around 10 points. Okay? Then there will be one file reading question worth 20 points and one Monte Carlo question worth 20 points. For each question, what I have done, and it's not in this exam over here, but what I have done for you is that I put in a rubric. So it will basically say, so each question is going to get its own page. That's just so that you have plenty of space. It doesn't mean that I expect you to write a lot of code. Make sense? Okay? Just plenty of page. And also because otherwise the formatting with the rubric didn't work out. So you'll have something like let's say this question over here. So let's say this question over here. Basically, I'll say if I was writing a rubric for this question, and it was 10 points, I'd say something like 2 points for iterating through the list, 3 points, 2 points for, 3 points for looking ahead properly in the list, 3 points for matching the pattern, and then 2 points for not going out of bounds. So each of those, notice that the way I presented that, 2 points for iterating over the for iterating over the word. That's the first thing you want to do in this problem, which is iterate over the word, right? And I'll get back to this, and I'll review this when I go over this question. Then 3 points for doing the look ahead. In other words, are you properly looking ahead because you're at a certain point, you need to be able to look at the next couple of characters. 3 points for detecting whether or not it fits the pattern. And then 2 points for making sure you don't go out of bounds. Right? So each of those actually so for each of these, so the rubric I give you are also hints. Like, this is the order in which you should tackle the problem. Okay? And if you can't do that part, skip it and try to fill out as much of the rubric you can so you can get as much partial credit on the problems you can. Like, for instance, the Monte Carlo method, I'm not going to reveal too much with that, but it is going to involve coin flipping, right? And it's going to involve flipping a coin X times. So it's like, so I start off the problem with, 2 points for writing a coin flip function. 3 points for writing a coin flip function. Then another 3 points for flipping that coin X times and recording that, And then so many points for, checking if it fits a sequence or whatnot. So basically each of these rubrics does give you the steps, at least the steps I would take if I were doing them. So, which may be different. But the idea here is that it helps you target what you should be doing in the problem to get as many points as possible. It also helps me with grading to know in advance what I should be giving credit for. Okay? All right. So the first question. So we'll start off with a 5-point warm up, then 6 10-point questions. Of those 6 questions, and I write this on the exam, the last of the 6 of the method writing questions. Right, so we do the method writing first on the exam, just the way I arranged it. I've arranged it differently on the exam because I wanted to go from, I wanted to give some questions that were more warm up at the beginning. For the last question of that section, I mentioned this and bolded in the exam. There's one problem I consider to be the hardest on the exam, and I let you know in advance what that one is. I let you know on that problem I consider it the hardest. So if you're struggling on it, skip it and come back, because you want to hit that file reading question and that question with regard that does other Sorry, the Monte Carlo stuff. Okay. So with that said, I am going to go ahead and get started on this practice exam. Okay. Okay. So these questions, as I mentioned, won't be on the exam, but I wrote them for the practice exam when there were questions like this. So they're good review though. The string value Howl's moving castle is a valid string. Why isn't it a problem that the single quote in the word Howl's isn't escaped? And the answer is that if in Python, right, you can use you can start a string like this. So Howl's, right? And if you open it with double quotes, you can use single quotes inside the string without any issue. If you use single quotes to open a string, using single quotes becomes an issue, but not double quotes. Does that make sense? Right? So just kind of subtlety there. And of course, if you just want to get around that, you can always do what you have to do in the other programming languages, which is use an escape character. Sorry, Howl's. There we go. What is the main difference between a dictionary and a list? Lists have an implied order. Dictionaries do not. Basically, lists have an index 0, 1, 2, 3, 4, 5, 6, 7, and it's always in that order. Dictionaries use keys, and the keys can be whatever the heck you want, right? The items in a list can be whatever the heck you want, but the indexes are always the same. But for a dictionary, the keys and the values, in other words, what are the equivalent to the indexes and the items, are whatever you want instead. All right. If L is a list, what does L : (-1) do? That's just shorthand for a copy of the list, but in reverse. If you had put on the exam and left off the bit about it being a copy, I probably would have just simply glazed over it and still counted it correct. The reversing part was the important part. Okay. And how do we use slice notation to get the last three characters of a string? Right, if we want to get the last three characters of a string, we would say, if we had some string, like, let me go to the idle over here. For instance, I like to eat tacos, right? If I wanted the last three, and let's just store that in S, just to make it more realistic. S, to get the last three characters of that, I do from the beginning, well, not from the beginning. This would give me everything but the last three characters, right? To get the last three characters, that means I want to start at -3 and go to the end, right? So remember, with slice notation is starting from going to. Okay. Hopefully slice notation is just something that becomes really useful, I feel, to do shorthand stuff with. You can survive without it, but it's just so useful for being able to write it. How do you simulate a coin flip in Python? This is kind of relevant because I did mention that this would be on the exam as for the Monte Carlo problem. We'll be doing a coin flipping problem in for our Monte Carlo problem on the actual exam. So here's three free points for you, right? First off, you got to make sure you have random, right? And on the exam, you can assume that those things are imported, no problem, right? Instead, what we're going to do is we're going to do def flip, and then we've got a couple different ways you can implement a coin flip, okay? The first way is you can do so you can return rand range, sorry, not random dot rand int, and then you can either use 0 or 1, using a 0 for heads, 1 for tail, or you could do 1 and 2, or you could use whatever you want there, right? You could use a number, right? 2 different numbers for your coin flip. Make sense? So that's one way to do this, right? A 0 as a heads and a 1 as a tail, right? Make sense to everybody on how to do a coin flip like that? And we'll go ahead and put those on the desktop as test review 2. Okay. So, and then we can call flip, and that would give us 0, flip, 0, flip, 0, flip, 1. There we go. So yeah, it gives us a random thing. Another cool way we could do it in Python is that we can do something like this. Sides is equal to, we have heads and tail. You could also just make a single string with H and T in it, right? And then you can do, and this is the way I like to do it personally because it gives me exactly what I want. You could return random, and this is my favorite, dot choice. And it says I'll choose something randomly out of the sequence. And now when I do flip, instead of giving me 0 or 1, it gives me a T or an H. And that's nice because guess what? I don't have to remember, wait, is 0 heads and 1 tail, or what is it? I just know H or T. Either one works, right? I don't care which one you use on the exam, right? It's just whatever you use, that's what you're going to use, right? Okay. So that's how you simulate a coin flip. If I have a coin that is simulated slightly in favor of heads, it would land head 55% of the time. How would you simulate this in Python using the random module? So again, there's multiple ways to do this. Def cheat coin, or cheat flip, right? We could do it the first way, which is that we could say result is equal to random dot rand int and 1 to 100, since it's inclusive, or I could do 0 to 100, this is inclusive here. And what I'll say is that if I want 50, is I could do something like this. If result is less than or equal to 55, right? If it's 55 or less, return head. Else, return T. Make sense to everybody? Right? If I wanted to weight it, I'd instead, and have a 55% chance, I would do a, I'd do it like this. Another way I could do it is I could do random, I believe, gives me a number between 0 and 1, and instead I could do it if it was less than or equal to 0.55, right? However, so long as and the final absurd way to do that, I feel, okay, there's one more way to do that that's kind of absurd, but hey, I love absurdity, is that you could do exactly what we did over here, actually. So instead I'll use this, and what I'll do is I'll do what we've done before, which is that, it's gonna, I will do 55 heads and 45 tails. And then I get to use random.choice again. It's rather a silly way to do it, but it works. It's, again, I don't care what you use. If it works, right? And I know that you're not going to be able to run your code and test it, but I can see the ideas, and they don't have to be perfectly syntactically correct, but I like however, it's the result that matters, not necessarily your approach. Okay, so let's get into this. All right, so we're going to tackle this one first because it's important, I feel. This is, as I mentioned, from a prior exam. Suppose we had a file named temperature.csv, which contains daily high and low temperatures recorded in Philadelphia. The file is composed of 3 fields per line containing the date. So here's a line. Each line contains a date, a high temperature, and a low temperature. And we separate it by commas. For example, the file might look like this. We can ignore the fact that there's spaces here. I just tried to do that to make it look nice. So just assume it's separated only by commas. Okay? And the dots, just pretend the file continues. It's not the entire thing. I don't want to see this copied into your code or something like this. write a program that calculates or prints the following: the day with the hottest high, the day with the coldest low, and the average temperature. So so I'm going to go ahead and do this as a function, because on the exam I'll ask you to write a function that takes in the file name. Def file reading prob. And we'll take in the file name, because we don't know. On the actual exam I'll ask you to do something like this where we don't know what the file name is. I'll write a function that takes in the file name, right? And this is a perfectly valid way to do it, even for this problem. So how would this program go about doing this, right? So what we're going to do in this case is that on the actual exam, I'll have a rubric along the lines of saying like 3 points for opening the file, and then 3 points for reading through it. And then it would be like, break it down, detecting the high, keeping track of the highest temperature, splitting the field, 3 points for separating out the fields, 3 points for detecting the highest high, 3 points for detecting the lowest low, 3 points for doing a running sum of the highest high, and then 3 points for like getting the average, and so on and so forth. So I would break it down and again in those directions. But we didn't have directions for this. So what I'll do over here is that we want to read this file. So that's the first thing we have to do. So if you remember nothing else, remember this is like 3 points on the exam. Read lines. Specifically, that's what we want to do to read the file. It's 2 lines specifically. First, we open it, and then we read the lines. Open. File name. And then we put it in read mode. And I'll say the file. And then I'll say lines or data or whatever. But we can get each of the lines in the file by doing the file dot read lines. Doing a dot read, that's also acceptable, but it might be trickier. And just simply iterating over it with a for loop, writing for line in the file, that also works. This is just the preferred way I like to do it. So for line in lines, plural, for singular and plural. Okay. So now what I have to do is I have to separate out the fields. I've got the date, so I've got the date, the high temperature, and the low temperature. So when I'm splitting something, I always kind of do it like this. Parts is equal to line dot, and remember to do this just like you did so this is just like your hurricane code, where we have each line has multiple parts separated by commas. So we just simply do line dot split on the comma. Make sense? And this will create a list with 3 items in it: index 0, index 1, index 2. If you want to cheat a bit and be a bit sneaky, you can also do this: date, comma, high, comma, low is equal to line dot split. And Python's actually smart enough to kind of figure that out, to assign 3 variables at once. It's kind of lovely. Okay, but I'm going to assume that you don't want to do that. We're panicking during the exam. We're trying to work as fast as possible, and we are not thinking about ways to optimize that. So you'll probably do it like this, because that is something we've done lots of times already. Parts is equal to line dot split. So we split it up. We don't care. So we do care about the day. So we want the day is equal to parts 0. The high of that day is equal to parts. I need to go faster. Parts 1. Low is equal to parts 2. And we're going to go ahead and, before we forget, cast them into an int. A float would also work. It just depends on how I'm recording the temperatures, but int or float works fine. I'm not going to. So we calculate int or float. and I'll just do it there before I forget. If you forgot on the exam, I might not even notice if you forgot to convert on the exam. That's an advantage of not writing your code, of not having to run your code, actually. So we do that, lines, okay, and now we can actually solve the problem. We need to keep track of the highest high, the lowest low, the day with the highest high, the day with the lowest low, and the average temperature of the entire file. So the first two are pretty much identical. We will have to make two variables for each of those, which is highest day and is equal to blank. Highest temp is equal to, let's make something very cold, right? Just so that the first value, whatever the first value is going to be hotter than that. And then the lowest day is equal to, and then the lowest temp is equal to something ridiculously hot, right? Because every day is going to be lower than that, okay? So let's go with that first part. How do we figure out what the highest day is? Well, for each day, we get the temperature, and then we say if the highest temperature is hotter than the highest temp, then that becomes the new highest temp. All right, there we go. And then we can record that day, which is highest day is equal to date. There we go. And then it's very easy for us to do the exact same thing for the second part, which is if low is less than the lowest temp, then lowest temp is equal to low, and lowest day is equal to the date. For the last part, the average, and that's all we need to do for that one to calculate it. Okay, so let's go ahead and I can return. I'll just simply put the answers here. I'll return them rather than printing them out, because on the exam I ask you to return a lot of stuff. So if you want to return multiple things, you can cheat in Python. Highest day, comma, lowest day. Great. Now, for the last part, we need to do the average, which involves a running sum. Total temp is equal to 0. And the average, and remember, to compute the average, what do? We add up everything, and then we divide up by the number of things we added. So num temps. Okay. Num temps red. Okay, the total temperature is equal to this, num temps red. And so for everything, and so we're asking for the average high temp. So what we'll do for that, what did we call it? We called it total temp. Total temp is plus equals the high. And then we do num temps red. We read another temperature. So we increase that by 1. So we increase it by, every time we read one of these lines, we say we've read an additional line, and we increase the high. And then let's see, we could just simply calculate the average as av temp is equal to total temp divided by num temps red. There you go. Make sense? Okay. And then we can simply return the average temp as well. But I'm not going to ask anything that requires you to return multiple things on the exam. That's just kind of, most of the time in the past I've done this as separate questions, but honestly that's a bit much to write. For these big questions that are worth 20 points, typically what I'll do is I'll have the problem on the on the back of one page, and then you'll have this blank area on the beginning, on the front of the next page to work on. And again, that's just to give you plenty of space. Okay? And that way you can look at both the problem definition and the problem itself. This one works very similar. I'm not going to go over it unless we have time. This one works very similar, where you just simply read each line, split the line into parts, but instead what you do is you then say for every number in the part that I just split up, if it's even, I add it to my running sum. Okay. So let's go ahead and do some of these method writings. So this will be the first part of the exam that you take. So not only will I give you rubrics, but I also give you these, which are example inputs and outputs, as well as how to start the method. Right, and you'll just simply write write in the space below it. So what we've got here is with un or un. That problem is that if the string begins with un, actually I can just simply, all right, yeah. So if the string begins with un, return the string without the un in front. Otherwise, return the string with un added to the front of it. You can assume that's at least 3 characters long. That's not really relevant for here, because Python's awesome. But in Java, when I asked this question in Java, you definitely need that. But here, but again, if it's never clear what that question's asking you, look at the input-output pairs, un or un. So untied, if I give you untied, you're going to return tied. If you give me unable, you'll return able. And if you return necessary, and if I give you necessary, you'll return unnecessary, right? If it starts with un, give me the word without un. If it has the un, if it doesn't have the un, add an un to it. So let's go ahead and figure that out. How do I know? So if the word starts with un, how do I know if it starts with un? I'll slice the first 2 letters. So word, if the first 2 letters are equal to, first 2 characters rather, are equal to un, then that's one thing. Do this, and then if I think for a second, I don't have to check if it doesn't start with un, because if it starts with un, it goes here. And then the else takes care of everything else. So if it begins with un, then I want to return the word without un. Return. So I can actually do that in one line with slicing. Un is only going to be the first 2 letters, so I can just simply say return the word starting at the second character, right? And go to the end. Otherwise, I want to add un in front of the word. Okay. And the way I do that, very simple, is just concatenation. Un plus the word. I feel like there's going to be questions as easy as this one on the exam, in my opinion. So, and it's easy, especially when you look at it. Okay, these ones are nice warm-ups. Min-max diff. Given a list of integers, return the difference between the maximum and minimum element. You may assume the list will have 2 or more elements in it. A lot of these questions have like very quick ways of solving them, and the more you know about Python, the shorter you can write it. Right? If you're just simply familiar with the for loops and stuff like that, then you'll probably end up with something like this. Right? So here we're looking for the difference between the biggest number and the smallest number. So here, 1, 2, 3, 4, 5, the biggest number is 5. 5 minus 1, the smallest number. 31 minus 15 is 16, so the biggest number in here minus the smallest number. Makes sense so far? And then 100 is the biggest number in here. Negative 100 is the smallest number in here. Biggest number minus the smallest number. So that becomes minus a negative becomes positive, so plus 100, so it becomes 200. But the reason I put this in here is also like we don't have to think about negative numbers. Math just works. So we just kind of just find the biggest number, find the smallest number, subtract and do subtraction. So biggest is equal to number. So what I'm going to just do. So you've got a few ways to do this. The naive way is I'm going to say assume the first number is the biggest, and also assume the first number is the smallest. Why? It just makes it easy so I can just easily do comparisons, right? I'm just going to assume that I'm going to start out thinking, okay, the first one's the biggest and the first one's the smallest. How do I find the biggest number? So for num in numbers, if num is if num is greater than the biggest, then guess what? That number is now the biggest, right? And then to find the smallest, it works exactly the same. If num is less than the smallest, well, the same, but in reverse, then the smallest is now that number. So I found the biggest, I found the smallest, and now I need to return the biggest minus the smallest. I'm sorry, I will try my best to send this out. I'm also just moving quickly because I want to make sure I get to everything as much as possible. Okay. Given a list of numbers, modify the list such that the first and last elements are swapped. Oh, right. One thing I wanted to show. You can also do this in one line, by the way. This particular question can be done in one line if you remember the built-in functions to Python. Return max numbers minus min numbers. Will I give you full credit for this? Of course. I didn't say you couldn't use this. If it's valid in Python, you're allowed to use it. Right? If it exists in Python, you can use it. I don't care. It's just that's your bonus for being clever. Okay. Swap ends. Given a list of numbers, modify the list such that the first and last elements are swapped. Okay. This one doesn't have to return anything because it's asking us to modify it. 1 and 5, 1, 2, 3, 4, 5 becomes 5, 2, 3, 4, 1. 15, 30, so we're just taking the last question, right? 15, 31, 21, 17, 28, and we see that the 28 has swapped with the 15. So def swap ends. For this one, the key here is to remember is to figure out that when you're swapping elements, you need something temporary to hold one of the elements in, right? Because when I swap elements, right, so the first element is located at numbers 0, and the last element is going to be located at numbers -1, right? But if I do this, then if I do this, I take the last number and put it in the first place. Now the last number exists on both the end and on the beginning, and I've lost the first number. So I need a temporary variable to store this, right? I can't just do these lines as much as I want to, because the lines happen one at a time, right? I cannot just do this, right? The lines happen one at a time. They're not going to happen at the same time. So what I have to do is I'm going to create a variable, a favorite variable of ours called temp, or will become a favorite variable, temp. We're going to store the number that was at the beginning, numbers 0, which then means it's now safe to overwrite that value because I've spacked it up. And now I can say at the end, numbers -1 is equal to temp. There we go. And we don't have to return this. You can, but we don't have to, because for a list like this one, when you pass it in, any changes you make to the list carry through. Okay. Because, all right. On a similar vein, figuring out the first half of the list, and then we got to get to some more difficult problems here. Yes, definitely some more difficult problems. Good. Okay. Because a lot of these have honestly been a bit easier than I would put on the exam. So first half. Given a list of things, return the first half of the list. Okay. So given 1, 2, 3, 4, 5, 6, return 1, 2, 3. Given 15, 31, 21, 17, 28, okay, so if there's an odd number, then then don't include the middle. That was kind of the rule I have. So we'll burn that bridge when we get there, right? Maybe we don't even have to. Okay. Am I mixing my metaphors? Yes. Okay. So the first half of the list, right, again, can be figured out through slicing. And it's actually a fairly simple one. First, in Java, this is harder, but we can do the list is equal to, okay, from the beginning to the what point? So where's the middle of the list? Middle is equal to length of the list divided by 2, I think. Let's find out. List up to, but not including the middle. So let's go ahead and just work through this because you're not going to have something to work on this. This is 6 long, so this goes up to. So this is 6 long. Length is 6. So middle in this case would be 3. So this would go up to, but not include index 3. 0, 1, 2. So it doesn't go up to, but it does not include this. Let's go ahead and look at one where we don't have numbers confusing us, right? The length of this one is 8. The middle of the list would be index 4, index 0, index 1, index 2, index 3. So this slice would go up to, but not include index 4. So this works for anything even. Now what about the odd ones? So this one is 5 long. Oh, wait. This would, in Python, doing this, dividing by this, gives me what? A float. It would give me 2.5. So in that case, what I need to do is integer division. Right? If you forget about that on Python, whatever. I might dock you a point, right? If you forget about that. That's like one of those things that once you run it, it becomes very obvious what the mistake was. So here, this would give me 5 divided by 2 would give me 2. Right? Because it would be 2.5, just throw out that 0.5. So 0, 1, but not including the 2. So it works for this output as well. Great. Okay, this one I've been giving as a practice question since 2016 because it's a really good one. Write a method called hasWildcat. Given an input string word, return true if the word contains the string cat in the middle. But the middle A can be any character. Car, again, this is adopted from Java, so that's why it says car weird like that. So what does that mean? Well, Kitty hasWildcat gives us a false. Tomcat, okay, has true because it contains CAT. And catnip with a 4 replacing the A is true, right? Because the middle T can be any character. Sorry, the middle A can be, it doesn't have to be an A. Make sense? So now this is a Boolean one. It's telling us true, we're asking true or false here. Okay, in order to do that, we need, and again, it's going to give us lowercases here because when I wrote this in Java, Java does lowercase true as opposed to capital. Anyway, for Boolean questions, we need to ask ourselves, is it more likely this is going to be, what is easier to do? To detect if a word has wildcat or to detect if a word does not have wildcat? And for us to code it, it's easier to assume the word does not have wildcat, right? So we'll return false by default. And then as soon as we determine the string contains a cat in it, we can return true. So let's go ahead and just kind of tackle this naively and kind of see where we run into, because I'm going to go through this as I feel like you would, right? On instinct, what we would do is say something like this: 4-letter in word, and then what we did iterate through this word and say, okay, the first thing we need to look for is a C, right? So if letter equals C, then that's at a point, then it might have a cat in it, right? In that case, I need to check, well, the next letter can be anything, but C blank T. So the character 2 after that, I have to check if it's T. Wait a second. How do I get the character 2 later after that? Or even 1 later? Because I don't have the index. I'm iterating through this without the index, right? Okay. That means I have to switch this up in some way. Okay? 2 ways to switch this up. If you've been doing Python, if you've been paying attention to your readings, you might be able to do this and get both for free. But let's assume that you don't. So that means, okay, if I need the indexes, I need to use the range. For index in range, len, word. If you forget to put the len in, whatever. I will kind of probably just knock you a point for that. Okay, on a 10-point question, that's 9 out of 10 still. Okay, so for index in range, length of word. Okay, so in that case, what we need to do is letter is equal to word index. Make sense? Okay, and at that point we say, okay, if letter is equal to C, okay, and then we can say 2 after. Okay, so I want to get the letter that's 2 after, right? Because so if I get to this point, right, this index, I get to index, I don't care what index plus 1 is, but I care what index plus 2 is, right? So I'll say word at index plus 2 is 2 after. So then I can ask if letter is equal to C and, or you could do an if statement in a nested if statement. That's perfectly fine. I just prefer to do it like this. If letter is C and 2 after equals T. Okay, in that case, I would return true, right? Because it's got a C and then a wild card and then a T. That's why it's called wildcat, by the way, because a wild character means it could be any character. So since it's wildcat, I know it's a dumb pun. And this is it if you want partial credit, because we have one issue. Because on the rubric, I would put on this one. I'd have one. When I was mentioning the rubric, I would when I was going over this earlier, I'd said the rubric for this one. If I wrote a rubric down, I'd say making sure this doesn't go out of range would be either 2 or 3 points. Because whenever we go do this, whenever we look at the index and we look 2 ahead, right? We have to ask ourselves, are we going out of bounds? Right? For Kitty, once we got to this character, it would ask if this is we would get the C over, we would say, okay, get the letter over here and then get the 1 2 after, then it would be out of bounds and we have an issue. So to avoid that, we want to say length of word minus 2 because I'm going to be reading 2 characters ahead. And that means that it will only check if these 3 characters are a C. It will also only check if those characters are a C. But that's fine, because once we get beyond that point, it's impossible to have cat in there anyway, because we're out of characters. So that's our full credit one there. Okay? Let's skip this one for right now. Given a string, return the sum of the digits 0 through 9 that appear in the string, ignoring all other characters. Return 0 if there's no digits in the string. Note s.isDigit test if the string is one of the characters. That's nice. So I've already kind of told us how to do that one. Okay, right? So this one, AA1, BC2, D3, 1, 2, 3 is equal to 6. 1, 1, 3, 3 gives us 8. And chocolate gives us 0. Because we had a 1 plus 1 plus 3 plus 3. That's why we had an 8. Okay, this one's fairly straightforward, I feel. But again, I'm going through this quickly so that I make sure I get to all the hard I want to make sure I get to as many problems as I can, and then I'm going to go back and go over any problems I skipped if I have the time. That was a weird way I said that. Tom. All right, so this one, again, this is running sum. Total is equal to 0. for letter in, or let's go with for character in Word, because it could be a letter, it could be a number. For character in Word, if the character, right, gotta actually type what I'm saying, if character dot is digit, and if you didn't have the digit, if you didn't have the isDigit function, we could say something like this: if char in 0, 1, 2, 3. And on an exam, I'd allow you to be lazy and handwrite if char in 0. If you wrote that on the exam, like physically hand wrote that, I'd accept that, you know. I know what you're doing. But we have the isDigit. Okay, if character is digit, great. Then in that case, what we'd want to do, whoops, cap lock, total plus equals. Remember, this, if you got, I would probably have in the rubric to remind you to convert it. Right, because it's a string. And then return it, return total, right? One important thing to note here, by the way, and this applies to people, probably to the people who are not in this classroom, but it's just in case you would miss it. Notice that I have not used the input function anywhere in my programs. Nowhere has the word input appeared. Nowhere am I asking for user input. Using input in these, when we're taking these parameters in, right? If you were to ask me something like this, if you were to do something like this, numbers is equal to input, this makes me extremely sad when I see this, because it means you don't understand how arguments work. It means that you haven't been keeping up. So don't use input, right? You're going to be doing everything through, you get everything you need through the arguments. Okay. So, anyway, that's just, and I have that noted in the exam notes as well. All right, some of the digits. Let's see. So I'm going to go ahead and actually skip ahead to the Monte Carlo stuff. Okay. So this is one that was written for an actual exam. In Monopoly, I've introduced this one before. In Monopoly, players move around the board by rolling a pair of 6-sided dice. Rolling doubles, which is 2 3s or 2 5s in a turn, is great because you get essentially an extra roll, being able to move again and buy extra properties. But if you roll another set of doubles, you can go yet again. So you can go do 3 turns in a row. But if you roll a third set of doubles, you don't get a 4th turn. You go directly to jail. Okay? So that ends your turn. So what we're going to ask ourselves is how often these things happen. Write a Monopoly program that simulates 100,000 Monopoly turns, where extra rolls to do a double count as part of the same turn. Your program should print out the number of turns where it's just a normal turn, numbers of rolls where you get an extra turn, the number of one where you get 2 extra turns, and the number of times you go directly to jail. Grading. And I break it down, and again, this is how I broke it down originally. Now I break it down even more. Points will be given as follows: simulating 100,000 dice rolls, handling doubles, handling 2 and 3 doubles in a row, presenting the data as percentages. Okay. So, def mono game from Monopoly, right? So this is so 2 things here. I'm going to have the game function, but before I do that, I'm going to, just like we had a flip function, because we're rolling dice, I'm going to do a roll, right? And I'm going to only write a function that rolls 1 dice because I need to roll 2 dice to see if they have the same result, right? Dice range in 1 through 6. So 2 ways to do that. I could do I could return random dot choice of a list 1, 2, 3, 4, 5, 6, right? Which is a silly way to do that, I feel. When we're dealing with numbers, we could just simply do random dot rand int 1 through 6. right? That returns the number 1 through 6. Rand int gives us the endpoint inclusive, okay? If you forget that on an exam, like minor mistakes like that are like 1 point. They're very minor, in my opinion, those kind of mistakes. Okay, it's the more of the conceptual issues that people lose points for. Okay, so monogame. Let's do this. Okay, so rather than returning true and false for this one, what we need to return is the number of times we roll, the number of percentage of rolls without a double, 1 double, 2 double, 3 double. So instead what we're returning is the number of times we rolled doubles in a turn. Or mono, so this isn't a game, but a turn. Okay. Not that it matters, but I like to be syntactically correct to not confuse myself. Okay, so D1 is equal, so dice 1 is equal to roll that, and D2 is equal to roll. Okay, so we roll separate dice for each of them. If D1 equals D2, okay, we do something else there. But if it didn't equal D1, if those two things don't equal, right, what do we do? Well, we didn't roll any doubles, so I'll say return 0. Make sense? Okay. And honestly, if you did this and then did this part where you did the whole part about doing trials is equal to, 100,000 and 4 in range trials. If you just wrote this, according to my rubric, that's half credit right there. Right? Even though we left quite a bit out and we didn't finish quite a bit. That's half credit. Like if you know the form for this, but you can't follow, then write the form as best you can. But don't try to copy paste like from a previous problem. Like say, okay, I'm writing this form out and then I need to do this bit. Like for instance, I don't want to see coin flips here when it's a dice roll, or dice rolls when it's a coin flip. That makes sense? So dice 1 is equal to dice. So the other thing you want to be careful of is not to do this, because this would be a new roll. Okay. So if dice 1 is equal to dice 2, that means it's a possible new turn. So in that case, we roll them again. And then we ask the same question. It's actually a rather silly way of doing this. So if they're equal to each other, then nah. But if we rolled a pair of doubles, and then we didn't roll a pair of doubles, okay? But if we rolled a pair of doubles, then we got to roll it one more time. Roll it again. And you kind of see where this is going. So we roll it again. And if they're equal to each other, D2. So if these match, then we just rolled 3 in a row, which is the maximum, and we'd go straight to Dale. Return 3. Otherwise, return 2. Whoops, no colon there at the end. So we could do it like that. We could also do it in reverse with the reverse check, which is saying we could do it in reverse as well, which may make sense to some of you more, which is saying if we didn't roll, so the other way to do this is say if they don't match, return 0. Else, they do, and actually we can just simply, in this case, if we did it like this, we actually don't have to nest anything. We can say, oh, if they don't match, return 0. Let's go ahead and roll them again. And then if they don't match, return 1. And we can just basically do this a few times. Make sense? So there's multiple ways to solve a problem. Some are easier than others. Make sense? Here we don't have to nest them because the return 0, the returns automatically stop a program from continuing. Or sorry, a function from continuing. So both those ways are pretty good. Both those ways are valid ways of doing this. Okay, monoterm. So whatever we're going to get the result is equal to this. And now we need to count the results. Okay, we need to count the results. So let's go ahead and call this num doubles instead, because we need to count the results. So I'm going to call this results is equal to, and this will file, and we're going to create a dictionary here. We could do a list as well. We could do a list with just 0, 0, 0, 0, where each index corresponds to the number of rolls we made. Or we could do a dictionary, where it's 0, where we had 0, 0, comma, 1, colon, 0, 2, colon, 0. But let's just go ahead and do a list. Actually, no, we're going to keep it even simpler, because during an exam, probably going to be doing this. No dubs is equal to 0. 1 dub is equal to 0. 2 dub, let's call them dub. No dub is equal, 2 dub is equal to 0. And 3 dub is equal to 0, right? Could do it like that because we know exactly how many we're going to do. All those are valid ways. The shortest way for me to write it, though, is this. Results is equal to this, 0, where the index is equal to the number of doubles. In which case what we do is that we take this and do results of num doubles, right? Index 0 refers to the number of times I rolled null doubles. Index 1 refers to the time I rolled 1 double. So we just take that and increment that by 1. And then what we can do is that to give ourselves the result, we just simply say for index in range, and this would make it display nicely, for index in range results print index comma results index divide by trials to get it to be a percentage, or at least normalized. Expected colon, right? So, and then I can just simply do this and run it, and num double, right? Again, these kind of things, that the errors that you're getting, is why I don't do this on paper. This is why I do it on paper, because as a beginner, you'd be spending a lot of time trying to fix that on the computer. Like, a lot of time. Trust me on this one. And there we go. Okay. Let's go ahead and work on the second Monte Carlo one. Okay. Oh, actually, let's skip this. No, before we move on to Monte Carlo one, this one definitely, as I mentioned previously, something like this will be on the exam. Okay, with the dictionary, where you have to count. So given a string, write a function that returns the most common letter. So on the exam, you might get something like, given a list of words, give me the most common word, or given a string, give me the most common word in the string, in which case you just split by spaces, right? So it all follows the same format. So this one, very easy to do. Basically, if you follow this format, it's a free 10 points, right? So given a string, write a function that returns the most common letter in the string. Let's go ahead and do that. Okay, def, most common, is equal to, so let's go ahead and, this goes for the most common letter in a string. Text, there we go. Most common, and I'll just call it letter because why not? Most common letter in text. Okay. So what we need to do is we make, when this one gave you the hint, it said use a dictionary to do this. So we do a count is equal to this. For letter in text. Okay. What we have to do is we ask ourselves, have I seen this letter before? If letter not in count. Very easy statement to write. If it's not recorded in our counts, then we record it. We say the count for this letter is equal to 1. Otherwise, the else, so we first asked, is it in our counts? In which case we've seen it once. But if we've seen it before, that's what the else says. If we've seen it before, then we've seen it an additional time. So what we do is we say, we take that letter, the counts we have, and increment it by 1. Okay. So that gives me, so if you do this, this gives you, I would say, about probably 7 out of 10 points if it was a 10-point problem. Okay. Out of 15, I'd say it was probably 10 out of 15. It really just depends. Okay, now what we're going to do here is we're going to say we need to find the most common one. So what we do is we say a most common letter. No, that's okay. Letter. Let's see. Best letter. Let's call it most letter is equal to, and then highest count is equal to 0. Okay. And so what we do now is we say for letter in count. And this goes over the keys automatically. Just the keys. Doesn't care about the values. It goes over the keys. So for letter in count, if count of that letter is greater than the highest letter. We've seen this format multiple times on the exam, in fact. So if something is bigger than the biggest thing we found, then that thing becomes the biggest thing now. I know, bear with me. I know it's boring. I know you're all tired. Okay, if count of letter is greater than the highest count is equal to count letter. Okay, and then we also would want to say that that letter is the one we want. Make sense? There we go. Good job. And then we would return most letter. Except we want it there, so it's not inside the for loop. There we go. So that's that one. Okay, again, I'm going to try to make sure I send this out via the announcements so you'll have access to it. Okay. Let's go ahead and do Monte Carlo, because I know that Monte Carlo is probably this point that I think a lot of people are worried about, right? Okay. So this one's another kind of tricky problem where it kind of shows, again, you don't want to, it's probably a bad idea to gamble with me because I'll cheat. The outcome of any fair, so the outcome for any fair coin toss has an equal chance of landing on heads or tails. If I flip a coin, it's going to be heads or tails. If I were to toss a coin 3 times in a row, there are 8 sequences that are equally likely, right? There's only 8 possible sequences. They all have an equal probability, right? All heads, head, head, tail, tail, head, tail, 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 head, tail, 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 head, tail, tail, head, or tail, tail, right? Those are the 8 possible outcomes. All are equally likely. This is not the lie, okay? This is the truth, okay? Suppose Professor Rosen challenges you to a coin flipping game for $100. You choose the sequence that occurs after 3 coin flips, such as head, tail, and then Professor Rosen chooses one, such as tail, head. One of you will keep flipping the coin until one of our 3 flip sequences occurs. So we keep flipping until the last 3 flips is one of our chosen sequences, right? There's 8 sequences, but you choose one and I choose one. Okay? So if I were to flip, so for example, a few games might end up like this. If you chose head, head, tail, and I chose tail, head, head, I might flip head, tail, head. You might flip head, tail, head, tail, head, tail, head, head, and I win. You do head, head, tail, you win. I do tail, tail, head, tail, tail. So because my sequence is tail, tail, head, and that's the last 3 characters that appear, I win. And over here, because the last 3 characters are head, head, tail, you win. You might start noticing something suspicious about these sequences. Okay, it seems like a fair bet. All 8 outcomes of flipping a coin are 3 times are equally likely. Then you remember Professor Rosen was mentioned he was sorted into Slytherin and is a bit of a trickster. So he probably won't be challenging you unless he's sure he's going to win. So let's write a program on the next page to simulate and see if your professor's trying to scam you, which he is. This is actually something called Penny's game, which basically the scam is, yes, all 3 sequences are more likely. However, if you choose one sequence, because we're flipping coins until we hit a certain sequence, if you choose a sequence, I can actually choose a separate sequence that is going to basically trump your sequence. It's actually fantastic. I can actually, in this particular example, you basically can only win if you only flip heads until you hit a tail. Whereas as soon as you flip a tail and you didn't win, then it's my victory. Okay, because my sequence encompasses your sequence. Okay? So let's go ahead. So we already wrote our coin flip function. Head, tail. Choose a side. Okay, so let's go ahead and write our function that does that game. Def flip game. We flip a coin until, so here we go. And we need 2 sequences. So, okay. Sequence 1 and sequence 2. Why am I giving these arguments? Because we're trying to get to head, head, tail, and the other person trying to get to tail, head, head, and I'm just abstracting this. Okay? Sequence 1 would be head, head, tail, head, head. Okay. So, what we're going to do is that we will say, is the first thing we need to do is we need to flip at least 3 of these. So, the flips that we're doing, let's call it flips. The flips we are doing is equal to flip plus flip plus flip to start it out, right? We need 3 coin flips to start it out. Okay? Make sense? We need to do 3 coin flips to start it out. And now we need a while loop as opposed to a for loop. Why a while loop? Because we don't know when this game is going to end. While loops are what we use when it's indeterminate. So while, okay, and there's a couple different ways we can do this. Okay, while sequence 1, but what we need to do is check while flips, while the last 3 flips, so from -3 to the end, are not equal to flip 1, the first sequence, and flips from 3 to the end are not equal to the second sequence, right? So while there isn't a winner, in other words, right? While nobody has won, what we got to keep doing is that we say flips plus equals another flip. We add another flip onto the end of our flips. Make sense? That's it. That's all we have to do for this one. We say, while the last 3 are not this, we just we just add another flip. Okay? So what do I do now? Okay. In that case, once we've got it done, we got to figure out who won. So we just stopped, so let's figure out who won. We can do that by saying if, and I'm just copying and pasting so I can go fast. If -3 is equal to if the last three characters are equal to the first sequence in this time, then return, let's see, let's go ahead and return true to say the player won, else return false, the professor won. And what we can do to calculate this is we can say, we'll now go down over to here, comment this out, and let's just go ahead and write the trials portion. Okay, trials is equal to 100,000. In this one, we're doing wins and losses, and the one on your exam is going to be counting wins and losses as well. So to keep it simple, wins is equal to 0. Okay, and then for in range trials, we're going to do this many, and what we're going to do is we're going to say if flip game, and then our sequences were head, head, tail, head, head, tail, and tail, head, head. If that's our game, right? If so if this is true, we return true if we win. So if that returns true, then wins plus equals 1. And then what we have to do is just simply print the number of wins we had, divide by the number of trials we had, and we'll see that Professor Rosen is indeed an awful human being who likes to trick his students because you'd only win 25% of the time. Because, again, look up Penny's game, Penney, if you want to check out how this game works. Okay? It's a very famous kind of scam. Okay. So let's see. Let's go ahead and go back to some of the other problems now. Okay, so extra practice. Okay. All right. So one of the questions that I want to mention that will definitely be on the exam is which I neglected to put on the practice exam, is something along the lines of this, which is a problem where given a list of lists, do something with it. Like, for instance, over here, so say this is the input. Okay. 2, 4, 6. So say this is your input. So this is a list of lists, right? Right? This is a list of lists. Everybody see that? So you'll get a question on the exam, something along the lines of this, and I'll solve this one for you. Where basically, I might say, hey, write a function that, given a list of lists of integers, and each of those lists have integers, give me the sum of all the items, of all the numbers, okay? Def list of list sum, right? Okay, so it's a list of lists. Now this looks terrible, but what this means is that you just need a nested for loop. To kind of, again, think about, okay, it's just a running sum, and you'll get something very much like this. Total is equal to 0, and we return total. Put that in, automatic partial credit, right? Because you know the format that you're using, okay? So now, what we need to do, and on the exam I'll also have a condition where it says if it works on just a straight list as opposed to a list of lists, right? Then it will be half credit. Okay, that's what I wrote on the exam. Okay, so what I need to do first off is for L in list of lists. So for every list in the list of lists, right? Now I've gone from this being a terrible problem to, okay, I'm just looking at this list. I want to find the sum of all the items in this list because it's a running sum. For num in L. Okay? So for each number, oh, I know how to do that. Total plus equals L. Sorry, not L, but num. Right? Total plus equals number. And that's it. Right? Lists of lists are nothing to be scared of. Let's do another. Def. Okay? Okay, here's one. That's probably going to be working. Let's see. Apple. It's going to be a bit bigger to find out. Banana. And then let's stop. Let's go. A. There's just two there, and then B, and then B. Okay. So for this one, sum of largest string lengths. So for this problem, I might do something along the lines of, hey, here's a list of strings. Give me the sum, find the biggest string in each list. Find the biggest string in each list and give me their sum. And give me the sum of all those lengths. Makes sense? So find the big string. So for instance, banana here, here, and here, right? And give me the length. So it would be 6 plus 3 plus 5. Make sense? So same deal. Running sum. Total is equal to 0. Return total on the bottom. Okay, for L, for list, in list of lists. And, you know, you've had practice problems on this on the textbook, I believe, where you've had nested lists. Okay, so what we do here is now that I've got this, I need to find the biggest string in here. Okay. Biggest is equal to whatever, that, right? For word in L, because it's a list of words, right? If the length of word is greater than the length of the biggest thing I found so far, then same thing we've been doing, the biggest thing is now that word. Awesome. So now we found, so this for loop, so this finds the biggest word inside that list. So inside each list, for each list in the list of lists, find the biggest word. And now, total plus equals the length of the biggest. Right? And that would get us, that would say, okay, apple's the biggest, no, banana's the biggest. Is the biggest, no, 3A's is the biggest. 3A's still the biggest. 1B's the biggest, 5B's the biggest. Nope, 5B's still the biggest. So it would be 6, and then it would go and figure out 3, and then it would go and figure out 5. Okay? So again, these kind of things are not that scary other than the fact that nested lists, all you have to do is then say, oh, for each list, I need to solve this problem. And then you have running sum. Okay, they're not really that scary. Okay. Since we only have like a minute left, let me just kind of quickly talk about how to solve the problems I skipped here. Okay, is everywhere. This one's on CodingBat. You can try it yourself. But basically, you just need to, again, like Wildcat, what you need to do is you need to look ahead. So as long as basically the index you're at or the guy next to you is one of those things, then it will be true. Okay. For this one, right? We did this one. And then for this one, summing the digits, there's two ways to do this. Use modular arithmetic. Use mod by 10 to get the last value, and then divide by 10 to throw it away. Or do what I expect most of you would do on an exam, which is be lazy, convert it to a string, iterate through it, and then for each character, convert it back into an integer. Because despite that being very inefficient, it gets the job done on an exam. Okay? And again, this one's on CodingBat again. You can try this out yourself. Just simply take this link, open the link in new tab, ta-da, right? And you can practice it yourself. And you just have to click the Python on the top. Oh, nope, that one is actually in Java, so bet. So in this one, let's see, count first even. Returns a new list of length count containing the first even integers in the next array. So I believe I did this one I know I did this one on previous years. There's not something like this on the exam, but it's still good practice. Okay? So good luck on the exam tomorrow. It will be, again, don't panic on it. If you again, every question is going to have a full page for you to write on. That does not mean that I expect you to spend the entire page, filled up with stuff. It's just that I'm giving you plenty of space, and it doesn't work with the formatting with the rubric to put multiple questions on the same page unless I make you really tiny. Okay? So I'm going to stop recording here so I can